computing conditional probability with this table. So you're at a school's open house and t-shirts and sweatshirts are being sold and you have 50 total. So it's always nice to see the 50 there. The one thing this chart doesn't give you is a total for like each row and each column. So I'm going to go ahead and write those so we have them. So like t-shirt, 8 plus 19 would be 27. 19 plus 11 would be 30. Oh, I skipped this one. 12 plus 11 would be 23. 8 plus 12 would be 20. So if you notice, the column and the rows both all add up to be 50. We may need those numbers in just a second. So the probability of a student, the probability we randomly pick one person and it's a student, you just want to take what you're looking at divided by the total amount. So this is all the way I always think about probability. What you're looking at divided by the total amount. So we're looking at the students. There are 20 students, and our total amount of people we're choosing from is 50. So that's 0.4, 0.4, 40%, whichever way you want to think about it. Probability of picking a student. Okay. The next one is the probability of a t-shirt and a student. So and is that symbol right there. T-shirt and a student is the intersection. So it's the intersect where t-shirt and student happen. So t-shirt and student would be that one right there. So you're looking at the students that are wearing the t-shirt and the students. So that would be 8 of them out of the total. 8 out of 50 would be 16%. So what's the probability you pick a student that has purchased a t-shirt? It's 8 out of 50 because there's 8 students and t-shirts. The next one is the tricky one, and that's what this topic's all about. It's probably going to tell you, or Alex is probably going to tell you to do a formula. I'm not about formulas and probability. You can almost use this formula right here, what you're looking at divided by the total for all of them if you think about it. But what you're going to look at here is this symbol right here means given. So you would say this, what's the probability that you randomly pick someone, sorry, I shouldn't have used yellow. What's the probability that you randomly pick someone that is wearing a t-shirt given that it's a student? So since it says given that they're a student, what you're going to do with that is you're going to separate out all the students. You focus on this row or column. This row or this column. Okay? So the only thing I'm looking at here is the student. It's a column on this one. So I'm looking at the student column. So if I come back up here, the student column, this right here is all that I'm looking at. I'm not paying attention to anything else. This is like I separated the students out, and I'm going to walk into the student room, and now I'm going to say, what's the probability that we pick a t-shirt out of those students? So I have 8 t-shirts out of 20 students. And that should be 40% also. So whatever this second part is what you're focusing on, the given part. Let me save this real quick and I'll do another one. Because I want to do a column just to show you. That was a column. We need to do a row, I guess. So on this one, again, I would go ahead and write down the totals or have the totals ready to go. So this is 30, this is 20, add these up, that's 25, that's 25, so that's 50, which is what they say. So we're looking at dogs and cats and whether they're vaccinated or not. So the probability of a vaccine would be how many total vaccines were there? There are 30 out of 50, so that's 60%. The probability of a dog and a vaccine. So dog and vaccine, this is the intersection, so where dog and vaccine meet, that's just 12 out of 50, so that's 24%. And you're welcome to use the formula that they explain after that. You can use those two numbers in a formula. But I like to think about it like we're here to learn how to think. So what's the probability that we randomly pick a dog given that it's a vaccine? So again, this means given. And this number right here, the second one tells us to focus on the vaccine. This is a row. So focus on the vaccine row. So I'm going to just focus on this row right here. So I put all the vaccinated ones in one room, and then I walk in there and I say, okay, what's the probability we pick a dog from that row? Sorry, I accidentally used my highlighter there. So the probability I pick a dog from that row would be 12 out of 30, which is 40%. Okay. So anytime you see this second one, you focus on that row or that column, and that's the only spot you're looking at. You separate them out.